Hi everyone. In today's class, we are going to discuss about the convolution theorem. Convolution theorem of inverse Laplace transform. There are various techniques to find inverse Laplace transform. One of the best technique is convolution theorem. Partial fraction method, long division method, convolution theorem are used to find inverse Laplace transform of the given function. Here in this class, we are going to discuss about the inverse Laplace transform. How can we find the inverse Laplace transform using convolution theorem? Before going to the class, first we have to know about the convolution of two function. Convolution of two function. If there are two function f of t and g of t, these are the two function. The convolution is defined by denoted by star. This is called convolution. Star is called convolution. The convolution of two function f of t and g of t is defined as integral 0 to t f of u g of t minus u. That is, in first function t is replaced by u. In first function t is replaced by u, and in second function t is replaced by t minus u. Then taking integration within the limit 0 to 2, integration with respect to u. Integration with respect to u. This is known as convolution. The convolution of two function is defined as integral 0 to t f of u g of t minus u into du. So this is the basic definition for convolution. With this concept, we are going to solve one problem, that is finding inverse Laplace transform using convolution. Let us see the problem. Using convolution theorem, find the inverse Laplace transform of s square divided by s square plus a square the whole square. So this is our given function. Let us start the solution using convolution theorem. Our convolution theorem says we are going to split up the given function into product of two functions, because for convolution we need two function f of t and g of t. For this purpose, the given function is separated into product of two function. This numerator s square can be rewrite as s into s, and denominator the whole square separated into s square plus a square into s square plus a square. The simple concept, x square can be rewrite as x into x, the same concept. So numerator square can be split up into s into s. Similarly, denominator square can be separated into s square plus a square into s square plus a square. Now apply Laplace inverse Laplace for both sides. So applying inverse Laplace transform for both sides of this equation, we will get L inverse of left hand side equal to L inverse of right hand side. So here we are having two functions. So L inverse applied for either of the function, s divided by s square plus a square, and then this is known as convolution, L inverse of s divided by this s divided by s square plus a square. Here we have two functions. So then apply the formula for convolution. What our convolution theorem says, if there are two function f of t star g of t means, we are already see the formula taking integration. In first function t is replaced by u, and second function t is replaced by t minus u. So here we are going to apply convolution theorem. Before that, apply L inverse for this function. Already we are having the formula for L inverse. L inverse of s by s square plus a square. What is the formula? Laplace inverse formula. Inverse Laplace transform of s by s square plus a square is equal to cos at. In numerator, s comes means cos at. In numerator, constant a present means it is sin at. So in our function, in numerator, s is presented. So the answer is cos at. So what about our given function? L inverse of s square divided by s square plus a square the whole square equal to first function L inverse of s by s square cos at, then 1 star. Again in second function also cos at, because s by s square plus a square, the formula is cos at. Now apply the concept of convolution. What is our convolution theorem says? Apply the formula. So apply the formula. What is the formula here? Our formula is f of t star g of t equal to integral 0 to t. In first function t is replaced by u, and in second function t is replaced by t minus u into du. This is our convolution concept. This is our convolution concept. Here also we are having two functions. In first function t is replaced by u. In first function t is replaced by u. What will get? Cos at. So integral 0 to t, in first function t is replaced by u. A instead of t, just to put u here. Then in second function cos of t is replaced by t minus u. So instead of t, just to put t minus u into integration with respect to u. So into du. uh, we are eliminating this convolution star by integrating the two functions. First function t is replaced by u and second function t is replaced by t minus u. Now we are going to integrate this function, but here there are product of two function. Product of two function. Cos a u is one function and cos a of t minus u is another one function. We are not able to find the integration directly for this function because there are product of two function. So for our calculation simplicity, the product of function is modified into sum of two function or difference of two function. Then only integration is very simple. For that purpose, the product of two function is reformulated into sum of two function. So apply the familiar formula. What is our formula here? Cos A cos B formula. Cos A cos B. What is our formula? Cos A cos B. So cos A cos B equal to cos A cos B equal to 1 by 2 into cos of A plus B plus cos of A minus B. This is our well-known formula to convert the product of function into difference or sum of function. So here we are having both the functions are cos functions. So I am choosing this formula cos A cos B is equal to 1 by 2 into cos of A plus B cos of A minus B. What is our A and B here? What is our A and B? In our integration, A here, in our integration, what is A? A is capital A is equal to AU. And what about B? B equal to AT minus AU. That is A into T minus U. A into T minus U. So AT minus AU. This is our A and B here. So apply the formula for this A and B. Then what can we get? Um, so what about the function will be? L inverse of s square by s square plus a square the whole square equal to 1 by 2 into 1 by 2 into, so let us consider this function 1 by 2 into integral 0 to t, 1 by 2 into integral 0 to t cos of a plus b, cos of a plus b. What is our a? Au plus b. B is at minus au. Cos of a plus b, then plus cos of a minus b. A minus b is au minus at. This minus into minus will be plus, so it will be plus au. It will be plus au. So over the integration into du. Uh, got it? Is it clear? Instead of a we are having au, instead of b we are having at minus au. So in this formula a plus b is a plus b. This is our b. We can also write what about b. B is this is our b. A into t minus u. A into t minus u. This b can be rewrite as at minus au. So that I take b as at minus au. So now simplify this one. Simplify this one. Then what can we go do? What we'll do? 1 by 2. 1 by 2 is treated as a constant. Just to simplify this step, integral 0 to t, this au and minus au will be cancelled. So cos at, simply we are having cos at, and then this au and this on au, au plus au is 2au minus at, then integration with respect to u. Integration with respect to u. Now we converted the product of function into sum of two function. Product of two function is converted into sum of, because here there is plus sum of two function. Now just to integrate, now the integration is very simple. Integrate this one. What about the integration formula? Integration formula, cos integration formula. Cos integration formula, integral cos nx dx equal to integral cos nx dx is equal to sin nx divided by n. This is our integration formula. Cos nx integration cos nx equal to sin nx divided by n. So with the help of this formula, integrate over the given function. What we get, equal to 1 by 2 is treated as a constant. We are integrating with respect to u. In the first term there is no u here. In first term no u. So simply cos at is treated as a constant. Integral du, only integration of du. Integration of du is simply u. Integration of du is u, because there is no u here. Cos at is treated as a constant. Similarly, uh, what about the cos integration formula? Cos integration is sin nx. So plus cos integration sin of 2au minus at. We are integrating with respect to u only. So what about the coefficient of u here? 2a. So this 2a comes in the denominator, because cos nx integration sin nx by n. The coefficient of x comes in the denominator. So the coefficient of u 2a comes in the denominator. So over the limit 0 to t. Over the limit 0 to t. Now substituting the limit, substitute the limit, upper limit minus lower limit. What about our upper limit? Is equal to 1 by 2. Limit is only for u. So cos at is taken as a constant. For upper limit t minus t plus, first apply the upper limit. Cos at into t sin of, in place of u just substitute t, 2at minus at divided by 2a. Upper limit over. This is our upper limit. This is our upper limit. Minus of lower limit. Lower limit is 0. So in place of u just put 0. Cos at into 0 plus sin of 2au. In place of u put 0. So 0 minus at divided by 2a. Upper limit minus lower limit over. Upper limit minus lower limit. Then 1 by 2 t into cos at, just t cos at plus 2at minus at sin at divided by 2a. Then 0 into anything, this will be 0. 0 into anything will be 0. So 0. Then minus sin of 0 minus at minus at divided by 2a. Divided by 2a. Then simplifying this one, we will get 1 by 2 t cos at plus sin at divided by 2a. Sin of, what about sin of minus theta? Sin of minus theta equal to minus sin theta. Sin of minus theta equal to minus sin theta. According to this formula, sin of minus 80 is minus sin 80. This minus into minus will be plus. So plus sin 80 divided by 2a. Plus sin 80 divided by 2a. Then is equal to 1 by 2 t cos 80 sin 80, what is the common term? Taking LCM as 2a, taking LCM as 2a. So here a sin 80, a sin 80, taking LCM as 2a, taking LCM as 2a. So sin 80 by 2a, sin 80 by 2a. So this will be 2 sin 80 divided by 2a. 2 sin 80 divided by 2a. This numerator 2 and denominator 2 will be cancelled. So our answer is 1 by 2 into t cos 80 plus sin 80 divided by a. Divided by a. Now the final answer is, this is our final answer. So in the given question, we have to find Laplace transform of, in the given question we have to find Laplace transform of product of two function. So L inverse of s square by a square equal to, what about the final answer? L inverse of s square divided by s square plus a square the whole square equal to 1 by 2 t cos at plus sin at divided by a. This 1 by 2 is common for both the two terms. This is our final answer. So once again I summarize this problem. Uh, Listen here. What is our given question? We have to find the inverse Laplace transform of s square divided by s square plus a square the whole square. Now what we do, the given function is product of two function. So the given function is split up into two function. Numerator s square is s into s, denominator is whole square is separated into s square plus a square into a square plus a square. After that, applying L inverse on both sides. So apply L inverse for each and every function individually. Already we are having the formula for L inverse. So L inverse of s by s square plus a square equal to cos 80. With the help of this formula, the first function is cos 80 and second function is also cos 80. Now we are having the product of two terms. Uh, Apply convolution theorem for eliminating this convolution, taking the integration over 0 to t. In first function t is replaced by u and second function t is replaced by t minus u. In first function t is replaced by u and second function t is replaced by t minus u. This is our convolution formula. So according to this formula, at is become au and sin cos at will be cos a into t minus u. So this direct integration is not possible for this. So we are applying one formula, cos a cos b formula. In cos a cos b, what about the answer? In cos a cos b, cos of a plus b into cos of a minus b plus cos of a minus b. So here we are having a is equal to au and b is equal to at minus au, cos of a plus b and cos of a minus b. After simplification we will get this step. So then direct integration is now possible because product function is transformed into sum of two function. Now applying the integration, cos integration, first in first term there is no u here. So cos at is treated as a constant and then integration of du is simply u. After that, this cos function will be integrated as sin of 2au minus at. The coefficient of u is 2a comes in the denominator. Then substitute the upper limit minus lower limit. Limit is for u only. Limit is for u, the variable u. So in place of u, substitute the upper limit and the lower limit. After substituting the upper limit and the lower limit, we can get the answer. Then simplifying further more steps, we will get the final answer. Okay, we will see later. Thank you.